Okay, chapter 3.3 lenses here, guys. Let's go. Looking at the first question, which diagram shows how a converging lens is used as a magnifying glass? Now, I've mentioned this in class many times. Whenever you see the word magnifying glass, which is one of the most popular questions in your IGCSE in terms of lens, you have to understand that the object should be placed in between the optical center and the focal point. So looking at these few here, this is definitely out and this is definitely out as well, alright. This object is placed in between the optical center and the focal point, and your image should be produced towards the left of your object. So B is definitely the answer here. This one just doesn't make sense, right, according to the light rays. Then question number 2 here. The diagram shows a converging lens forming an image of an object. Which statement about the image is correct? It is real, definitely not true. Any magnifying glass, this will be virtual because it is formed by virtual light. It is real, for sure not true. It is virtual and can be seen by an eye at X. Nope, this is not true as well. Whatever you form in a magnifying glass, the virtual image can only be seen by Y. So moving on to this next question here, an image is formed by a plane mirror. Plane mirrors will generally create virtual and laterally inverted images. Here. A second image is formed by a lens used as a magnifying glass. This will also be virtual as well, which row states the nature of these images here. Plane mirror for sure, virtual. Magnifying glass is virtual as well. So donkey is the answer here. Alright, look at the next question. The point labeled F are the principal foci of a lens. The beam of parallel ray is incident on the lens, which diagram shows the path of light after it passes through the lens. Once it passes through the lens, they are supposed to converge at the principal focus. So B is naturally the answer here. And question number 5, the incomplete ray diagram shows two rays of a light passing through from one point of an object through a thin converging lens. Which type of image is formed and which side of the lens is it formed? Yet again, you'll notice that these two light rays are diverging. Means to say they are actually going to converge somewhere at the back here, and this is obviously a magnifying glass yet again. So it's definitely going to be virtual, and the image will definitely form on the left lah, right? So C is the answer here. And moving on to question number 6, a converging lens is used to make an image on a screen. If any image can be projected on a screen, it usually means to say it is real. And since it is real, most of the time it is inverted. Actually, when I say most of the time, I mean all of the time, guys. So naturally, A is going to be your answer here. Then the diagram shows an object O in front of a thin converging lens with focal length F. At which point will the lens form a sharp image of the object? A sharp image means to say it's going to be clear image, where the clear image can only be formed where all the light rays are supposed to converge. So you could use the same concept, horizontal line, cut through the focal point here, then after that cut through the optical center. I'm pretty sure you'll get an answer that is somewhere around donkey if you use proper rulers. So donkey is naturally the answer here. Then looking at the next part here, figure 7.1 shows an object and its image formed by a converging lens. One ray from the tip of the object to the tip of the image is shown. Figure 7.1 is drawn to full size here. Alright, then place a tick in all boxes that correctly describe the image. Obviously this image here is diminished because it's smaller, right? It is definitely inverted because it's upside down, and it is definitely real because it is formed on the other side of the lens, right? Then after that, figure 7.1, draw a ray passing through the principal focus of the lens from the tip of the object. Label the principal focus F here. So basically this question here, they're asking me to find where the principal focus is, right? In this case here, what I actually have to do is, usually what we do is we draw the horizontal line, cut through the focal point, cut through the optical center, and this is where the image is formed. In this case here, we actually need to work backwards around, right? So what we do is we're still going to draw the horizontal line, And once we reach the normal of the lens here, right, what we do is we use a straight line and we cut through directly onto the image here. Wherever it cuts on the principal axis, this is where your focal point is, guys. Alright, so it's just a matter of doing it inversely. Then use the ray you have drawn in B to determine the focal length here. I think if you do the correct measurements, you are supposed to get somewhere around 2.6. I can't remember. It will be somewhere around 2.5 or 2.6 cm. If you drew it correctly, just measure the distance from the optical center to the focal point here. Whatever this length is, write it down, it will definitely be correct. Okay. Then finally, draw another ray, not passing through the principal focus of the lens, that passes through the tip of the object and the tip of the image here. Now, if I cannot draw the principal focus, what I cannot do is draw a horizontal line here and draw it like this, because this would have been the principal focus of the lens. So instead of drawing this, what I have to do is I have to draw one straight line, reach the normal here, and then bend it towards the tip here. It doesn't matter where you draw, as long as you draw in between them one straight line and go directly to the image, that will be correct already. Okay. Then after that, figure 7.1 shows a converging lens and its principal axis. The point labeled F are each the principal focus of the lens. On figure 7.1, draw two rays from the top of O to locate the image of O here. So what you're going to do is same thing lah. You're going to use your ruler, horizontal line, cut through the focal point, and one straight line that cuts through the optical center. Wherever the lines meet, that is where your image is formed. So from here, underline three terms below to describe the nature of an image produced by a converging lens used as a magnifying glass. Magnifying glass is definitely going to be larger image. It's definitely going to be upright, and it's going to be virtual. For those who cannot remember this, you can refer back to the notes. It's definitely going to be there. Alright, then moving on to the next part here. Figure 7.1 is a diagram of a converging lens used to produce an image of an object. Each point marked F is the principal focus. Write down three terms that describe the image produced. Obviously here you can see that it is real, it is inverted, and it is definitely going to be magnified, right? So all you need to write here is real, inverted, and magnified. And this is how you're supposed to get your 3 full marks, guys. Very straightforward here. Alright, then moving on to the next part here. Figure 7.1 shows a converging lens and its principal axis. Point F1 and F2 are each the principal focus of the lens. Yet again, I noticed that the object is placed in between the optical center and the focal point. I know for a fact that this is going to be a magnifying glass. On object O placed between F1 and the lens, figure 7.1, draw two rays from the top of object O to locate the image here. Same concept, you're going to horizontal line, cut through the focal point, cut through the optical center, then you dot your lines. You draw dotted lines here indicating that they are virtual light. Wherever the dotted lines meet, that is essentially where your image will be formed. Then after that, object O is moved to the left along the principal axis so that it is further than F1. So right now the new object is here lah. Figure 7.2 is a diagram of the new arrangement with the new image shown. Okay, this is the new arrangement with the new image shown. Right, underline three of the terms below that describe the image shown in 7.2. Obviously, it is enlarged because it is longer, right? The image is longer than O. It is definitely real because they are on two sides of it and it can be projected onto the screen. It is definitely inverted lah, right? Because it's pointing downwards here. Okay. And then moving on to the next exercise. Images formed by lens and mirrors can either be described as real or virtual. Which row describe real and virtual images of a point? to be real is to be able to be formed on a screen, and virtual means to say it cannot be projected on a screen, right? So looking here, form where the light rays meet, this is possible. Form where the light rays meet, possible. Form where the light rays appear to diverge, this is not possible. Form where they appear to diverge, not possible. An image in a plane mirror is an example of a virtual image. This is possible. Projected onto a screen, not possible. For virtual images, you cannot project it onto a screen. So A is the logical answer here. A thin converging lens has a focal length of 6 cm. An observer looks through the lens at an object which is placed 4 cm from the lens. If the focal point is further, that means to say this is yet again going to be a magnifying glass. Which description of the image is observed correct? It is definitely going to be enlarged, and it is definitely going to be virtual. So donkey is going to be the answer here. Then question number 3, which diagram correctly represents rays of light passing through a converging lens in the camera? Looking at A, this could be possible because the light rays are converging here. This is definitely not possible because the light rays are not going to go straight. This is not possible as well because they will not converge before the lens. This is not possible as well because the light rays are not going to go straight. So answer is only A here. Alright, then after that, a small object O is placed near a converging lens as shown. The lens forms an image I. The image and object are on the same side. So this most likely is a magnifying glass, right? Which statement is correct? Image I is diminished, definitely not true. Image I is inverted, magnifying glasses will not be inverted. Image I is real, definitely not true. If they're on the same side, they won't be real. Object O is closer to the lens than the principal axis, looks logical because magnifying glasses will always have the object placed in between the focal point and the optical center here. Alright, then next one here, a converging lens produces an image of an object O. The focal length is f. Which position of the object produces a virtual image? Yet again, if you want to have a virtual image, it is basically like a magnifying glass. It should be placed in between the focal point and the optical center. So looking here, A is the only logical answer, yeah guys. Alright, then moving on to this next part here. Figures 5.1 drawn to full scale show a thin converging lens of focal length 3.5 cm. Okay, if it's 3.5 cm and they say that every 5 boxes is 1 cm, then obviously I'll need 1 cm, 2 cm, 3 cm, and 3.5, right, which is somewhere around here. It'll be somewhere around here. Okay, and then this one also same thing. After another 5, it will be somewhere around here as well. This is going to be the F, and this is going to be the F. The object of height 4.4 cm is placed 7.5 meters cm away from the lens. On figure 5.1, draw rays from the tip of the object to locate the image. So basically what you're supposed to do is you're supposed to draw a horizontal line, cut through the focal point using a ruler, cut through the optical center straight away here, right, wherever the lights meet, that is where the image is going to be formed. And depending on how long this thing is, you're going to determine the height of the image, which, if I remember correctly, will be somewhere around 3.8 cm. Right, it's going to be somewhere around 3.8 cm. And state whether the image is real or virtual. State and explain whether the image is real or virtual or not. I know for a fact that the image here is definitely real. Why? Because it can be projected onto a screen. This is a super standard answer, and if they ever ask you to explain whether an image is real or virtual, right, you just have to mention that it can or cannot be projected onto the screen. In this case here, obviously they're on both sides, so they can be projected on the screen, and thus it is definitely real. Alright, then moving on to this next part here. Figure 7.2 shows the principal focus f1 and f2 of a thin converging lens. Figure 7.2 also shows an object O of height 1.2 cm. close to the lens, two rays from the tip of the object O are incident on the lens. Figure 7.2, continue the path of these two rays for a further distance at least 5 cm. So they're basically asking me to draw the light rays, right? I'm supposed to cut through the focal point here and cut through the optical center here. Yet again, I noticed that they are not converging, right? It means to say it's a magnifying glass again. Using your answer in B1 to find the mark on 7.2, the image I of object O, and label this image. You're basically supposed to draw the dotted lines here, the dotted lines here. Wherever they meet, that is essentially where your image is, and you're supposed to measure the height of this image, which is somewhere around 3 cm. I think it will be somewhere around 3 cm, right? But you're supposed to do it properly in the exam, right? Now after that, state and explain whether I is real or virtual. Obviously it is going to be virtual. Image I is virtual because it cannot be projected onto a screen. Super standard question with a super standard answer, guys. Alright, and moving on to this next part here. A thin converging lens is used to produce an image I of object O. Figure 8.1 shows OI and the screen on which the image is produced. So if the image can be projected onto the screen, obviously this is going to be real. On figure 8.1, draw a straight line to represent a ray from the tip of the arrowhead of object O to the tip of the arrowhead of object I. Draw a vertically dotted line to indicate the position of the lens. This dotted line must be extended above and below the principal axis. So basically, if I want to find where the lens is, I have to think back about the light rays is supposed to cut through the optical center, right? So what I have to do here is use my ruler, right? And then just draw one straight line to where the image is lang. Wherever it hits, right? Wherever it hits the principal axis, this is where the lens is. And then from here, if I know the lens is somewhere around here, all I need to do is just draw dotted lines upwards, dotted line upwards, and also dotted lines downward here. And this is essentially where the lens is, right? Now after that, draw a second ray from the tip of the object O to the tip of object I. This ray should pass through the principal axis. Since you have the normal already, it's very straightforward already. You just need to draw the straight line here, and then from here you just need to connect it all the way, right? Connect it all the way until it reaches the image here, right? Wherever the light rays hit, that is essentially where your principal focus is, right? Then after that, they ask you to determine the focal length of the lens. If you measure that correctly, you're supposed to get somewhere around 2.4 cm. You're supposed to get somewhere around 2.4 cm. Use a real ruler to measure in exam. Image I is further from the object than object O is from the lens. The image I is described as an enlarged and inverted. State and explain one other characteristics. Yet again, it's either real or virtual, right? It's definitely going to be real because it can be projected onto a screen. Yet again, indicating how commonly asked this question is. You have to know how to answer this. Real because it can be projected on a screen. Virtual because it cannot be projected onto a screen. Alright, then this next question here is a very interesting one. On figure 7.1, a converging lens projects a sharp image of object O onto a screen. Sharp image means to say the light rays are going to converge properly, right? Complete the path of the two light rays from the object to the screen here. What you need to do is just extend these lines here, extend these lines here. And since there's a sharp image on the screen, you are supposed to extend it all the way until you reach here and extend it all the way until you reach here, right? This will be where the image is formed. Then the next question here, the converging lens A is replaced with a thinner converging lens. The object O and the screen remains at the same position. The thinner converging lens has a longer focal length. If it has a longer focal length, it means to say it's going to converge further away from the screen, right? Complete the path of the two rays from object to the screen here. Just now here is the focal point, right? That's why it converges at the screen. If it has a longer focal length here, it means to say the light rays are still going to extend here and they are going to converge at the back of the screen here, right? So this is where you're supposed to get your answer. Then, moving on, a converging lens is used as a magnifying glass. The focal length of the lens is 10 cm. Describe the position of the object in relation to the lens here. So basically they're asking you where should you place your object if you want it to be a magnifying glass, right? The object must be placed in between the focal point and the optical center, right? And after that, describe the position of the image in relationship to the lens and the object. The image produced will be further away from the lens than the object, which makes sense, right? Because if it's a magnifying glass, it's going to produce an image further away. Give 3 properties of the image formed by the magnifying glass: for sure, virtual, magnified, and also upright here. And this is how you're going to get your full 4 marks here, guys. Alright, then moving on to the final page here. On figure 7.1 shows the position of a converging lens, its principal axis and the object O here. Yet again, the object is placed in between the focal point and the optical center, magnifying glass. Each principal focus of the lens is F. On figure 7.1, draw a ray to locate the position of the image formed by the lens. If they ask me to draw one ray only, then draw a ray. Oh, it's probably going to be here, right? Maybe like dot here. Oh, a ray diagram, sorry, a ray diagram, then it's going to be here and here. And after that, dot. Wherever the light rays meet, that is where your image is. Then, yet again, describe the nature of eye. It is definitely virtual, magnified, and upright. Finally, image formed by a lens sometimes have colored edges. This suggests a reason for this. The only reason you could have color edges is because dispersion is occurring, right? White light that shines into the lens somehow goes through some form of dispersion and you get different colored edges. So all you need to write here is basically dispersion occurs in the lens. Okay, dispersion occurs in the lens here. Moving on to the final exercise here. Figure 7, a converging lens can be used as a magnifying glass. What would the nature of the image be? Virtual, upright, and enlarged. Super standard question, super standard answer. An object O is placed in front of a plane mirror as shown. Which row is correct? Position of the image is obviously going to be here. Nature of the image, since it is a mirror, it is definitely going to be virtual. So B is the definite answer here. Which statement about converging lens is correct? A real image of an object projected onto a screen by a converging lens is always inverted. Possible. The image formed by a converging lens is always upright. Not possible. Image formed by a converging lens when used is a real image. Not possible. Parallel rays entering a converging lens are focused at a distance greater than the focal length. Not possible. So A is the only answer here. Okay. Figure 7.1 shows a converging lens and the image I form when the object is placed to the left of the lens. The principal axes are labeled A and B and the center is labeled C. Figure 7.1, draw 2 rays to locate the position of the object here. Very straightforward. Draw one ray that cuts through the optical center here. Then after that, draw another ray that cuts through the principal axis. Until the normal here. And after that, draw one more ray that is directly straight line horizontal with the principal axis here. Wherever the light rays meet, that is where your object will be. It's just working the other way around. Ring all the following distances that are equal to the focal length of the lens. Focal length is going to be AC, CB, AC and also CB here. Okay, and finally, the distance between the center of a thin converging lens and each principal focus is 5 cm. Describe what is meant by the term principal focus of a thin converging lens. By definition, the principal focus or the focal point is a point where all rays converge on the principal. It's basically a point where all the rays converge, right? They're supposed to converge, cut on the principal axis here. Then finally, the lens is used as a magnifying glass to produce an image I of an object O. This is the image I. The O is missing, so I assume they want you to find it. Underline the terms that describe the nature of the image produced by a magnifying glass. Yet again, definitely enlarge. It's definitely going to be upright, and it's definitely going to be virtual, right? Then here, on figure 5.1, marks both the principal axis and label each and every one of them. How much is the principal focus? 5 cm away. Each 5 box is 1 cm, so 1 cm, 2 cm, 3 cm, 4 cm, and 5 cm here. Somewhere around here, the principal focus. Same thing for this one as well. 1 cm, 2 cm, 3 cm, 4 cm, and 5 cm. Somewhere around here. Right. And after that, make sure you write F. By drawing on figure 5.1, find the position of object O to the image here. So basically what you have to do is you first have to yet again draw one direct straight line here, right? Then after that, with this here, you're supposed to draw one more straight line. You're supposed to draw one more straight line and find where the object O is first. Oh, sorry. Yeah, it'll be here to here. Sorry. You have to cut through the principal focus, right? Because if you think about it the other way around, it's just a matter of working backwards here. From here, once you have this already, you just need to be somewhere around here. Okay, and this is essentially where your image, your object should be, right? But when you draw in the real exam, you make sure that these lines are dotted. Don't draw it as a solid line, because these are virtual light, and virtual light should always be drawn as dotted lines. And then finally, using figure 5.1, determine the distance of object O from the center of the lens. You're supposed to determine this distance to this distance here. It will be probably at 1, 2, 3, somewhere around 3 cm, if I'm not mistaken. Yeah, somewhere around 3 cm here. And this is how you're supposed to answer all these questions here.